G'day champions, we've got a Mackie ProFX 8 version 2 here. It's doing something that a lot of these things do, and they power cycle. So let's have a look at the symptom. It's got a built-in power supply, so it's just got the 240 volts going straight in. This power supply is automatic, so anywhere between 100 and 240 volts it can use without having to flick any switches. It detects the voltage, changes the duty cycle to suit with a feedback loop, but we'll go over that in a minute. So I'll just turn this light off. Hopefully you can see the mute light there is flashing. The level set lights are flashing sort of regularly. It's not showing as regularly with the shutter speed as it is. It's going bang, 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 bang very evenly. So that's power cycling. It's flicking on and off, on and off, on and off. So let's open it up and find out why that is. Now, to remove the bottom cover on these things, you've got simple screws here, but they go underneath the end caps, which are made out of plastic. So we've got to back at least one of them off so we can slide the base out from one end. Now we've opened the toasted cheese sandwich. We can see that we don't have a lot of room to play with on the cables. So we have to remove a ribbon connector. We'll remove the one from the actual board. Make sure that we're not plugged into the mains for this. These aren't instructional videos, by the way. I'm not doing them so you can know exactly what to do and fix your own stuff. I'm doing them for entertainment only. If you tried to repair your own stuff, do it at your own risk. Simple as that. I take no responsibility. So everything looks pretty good on the power supply. There's no clear explosions. The mains fuse is still alright, but in my experience I've found one of the diodes going short circuit in the secondary, which is in this area, to cause this fault. So we'll check that there's no residual voltage on the primary side, and then we'll start investigating on the secondary. So I'll just snip this cable tie so we've got a bit more play on the cable there and we can lay it flat. Alright, so looking at the schematic here, we can see we've got some input filtering. We've got our bridge rectifier, and then we should have DC on this side. So C6 is the main reservoir cap, supplying the bulk of the power to the transformer, and you've got a little coil down here which is controlling or powering the controller chip down here. So this has the smarts in it, and that is detecting a short, and it's trying to reboot every time. I suppose you could say reboot. The main MOSFET here is what switches that primary coil. Basically, what a switch mode power supply is a frequency converter here. So it takes your 50 Hertz, changes it directly to DC, then uses this chip. That provides the oscillator as well as the pulse width modulation, which controls this coil here via switching on and off via that MOSFET. This is the super back of the napkin version. So then from that side on, it's basically a conventional power supply, but it just runs at much higher frequency. So then you can use smaller capacitors and you can use a smaller transformer. That's the main idea behind a switch mode power supply. There's nothing fundamentally different about a switch mode power supply other than you're changing the frequency and the pulse width of the input, and you've got some feedback circuitry which via that optocoupler tells the chip what it's got to do. Has it got to change the duty cycle to be smaller or larger to get the voltage that's expected on the secondary? So it's not rocket science. There's a little bit of stuff down here that sometimes trips you up in terms of the kickstart circuitry, because this has got to start firing before it has power essentially. So when you first click it on, a pulse will be enough to power this tiny little circuit down here which draws, a bee's dick of current. Then that kicks off, and then that starts controlling this coil, and then it powers itself. It acts like a secondary. So it takes a little sip of the juice and then keeps providing the juice via that MOSFET and that coil. So anyway, we have a short somewhere. So what we're going to do is have a look at these rails and see if there's any shorts. I think it was on the plus minus 15 volt rails on the last unit I looked at, but we'll double check that. So the tricky part with this board is there's literally not enough connections to be able to measure the diodes from the top of the board. So we'll just remove these 4 screws and just lift her up so we can get to the bottom traces and know what we're looking at. Alright, so there's the bottom of the board. Again, there's no real indication of anything dramatic happening here. So we'll just measure some diodes and go from there. So we've got our meter set on diode test. That one's measuring okay. Forward voltage drop about 0.3 volt. That one's measuring okay. And that one's measuring short. So that is the plus 7 volt rail. That's D4. So that is a 3 amp 60 volt diode that's gone short circuit. And it's saying here it's rated at, or it's expecting 600 milliamps. So we're expecting plus 7 volts plus minus half a volt at 600 milliamps. So really that should be well rated for that. So I'm not sure if it copped a spike or what, or if there's a short further down the rail. So we'll have to investigate that and see if it's drawing more current than it should. Alright, so that diode's an SR306. So just had a quick look on DigiKey. No longer manufactured. C substitutes. So that's a Schottky 60 volt 30 amp. Let's have a look at the substitutes down the bottom. MBR 360. Alright, so had a quick look in the parts box. That's the box where I haven't gotten around to organising them into the drawers yet. And I've got the MBR 3100. So these are 3 amp 100 volt Schottkys. They're fine. So we've just got another 40 volts there in the peak inverse voltage. So they'd be good for the job. 3 amp as well. We'll see how we go. We'll monitor the current and see if anything's short beyond that. We'll run it without the ribbon connector plugged in. Just make sure it boots up okay and the voltages are stable. Then we'll plug the ribbon connector back in. Just check that nothing's overloading it. So just put a bit of fresh solder on there, primarily to get the a bit of flux out of it. This is the bit where it goes wrong for a lot of people because they don't have the right soldering equipment. You need a temperature controlled iron, flux, multi-core flux cord solder, electronics type. I'm using Loctite, previously known as multi-core 362 6040 solder. So that's 6040 alloy, 0.7 mil. I've got a fancy desolder gun with the right correctly sized tip for the job. If you don't have that, the next best thing is desolder braid. With solder connections like this, you can't really get the desolder guns, the solder pumps, these things. You can't really get them where you need them. You can have a go, but you never get all the solder out. And if you keep trying, you're going to overheat that joint and possibly damage the trace or rip the pad off. So that component is still solidly in there. So now we've got rid of most of the lead-free stuff at least, because that's got a high melting point. We can try it with a bit of braid. Generally like to use a bit of extra flux if I'm using braid. And that's got us pretty well there. I don't think the component's going to fully drop out of its joint like it does with the desolder gun, but it's a lot better than the sucker. That component comes out just with the braid. Ow. So the braid is a good solution as long as you're using a bit of extra flux, and make sure it's the flux braid as well. Doesn't actually say on there, but that's actually got like a white powder on it. It comes off on your fingers. That's flux, and that helps the solder flow. Without flux, you're pushing shit uphill to do anything, and you're going to damage stuff. So you definitely need at least maybe a gel flux if you don't have a flux braid, but just get the flux braid, and different ones are better or worse. You've got to try a few out. The Heiko stuff seemed okay, but I don't think there's enough flux on it. I've found this Chemtronics to be pretty good. Other guys have other good brands. There's plenty out there. It's sort of like taste test thing. So we'll put the new diode in. Be cognizant of the symbol down there showing where the cathode is. If you don't know what a cathode is, put the soldering iron down and get reading. Just solder that in place. These power diodes, they soak up a fair bit of heat, so you need to sit there a little bit longer than you do with some components like resistors and stuff. Cut off the excess. We'll clean off the flux using a bit of 99 or 100% isopropyl. They call it 99.997 or something because you can never get truly 100% isopropyl alcohol because it's hygroscopic. It absorbs moisture from the air. So there's always a bit of water in there, but at least this stuff is pure when it's manufactured, and then it just absorbs a little bit from the atmosphere. Don't try and use the stuff from the hardware store. Usually that's only 70%. It's meant for cleaning windows and stuff, or just general disinfectant work, but the excess moisture can cause problems with electronics. Alright, so I checked all the voltages, unloaded, and they're all within tolerance. So moment of truth, we plugged in the main board. Oof! And she's alive. No pulsing. Got phantom power. Just check that phantom power. You can see there between pin 1 and pin 2 or 3, you've got about 48 volts. That's what we want. Near enough's good enough for rock and roll. So we've got phantom power and the digital system appears stable now. Nothing's rebooting or anything. So next I'll plug it in, have a listen through the headphones. So she's pretty dirty. We'll give it a clean up. At least the faders we'll clean and lube. The rotary pots, we'll cycle them, see how they go. It's a bit difficult to get into them to give them a clean and lubrication without taking the whole thing apart, and that's sort of not in the budget for this one. But we'll just clean the surface, see how it performs, just listen through the headphones, give it some signal, see if there's any intermittency, and go from there. Alright champions, so we gave her a bit of a clean up. There's a little bit of scratchiness on the gain controls. The EQ and the auxiliary sends are pretty well stable, as well as the pan pots. The gain controls get more touchy towards the top of their range where they're less sort of linear. But that's pretty extreme that you've got to have it cranked all the way up. And it only seems to be crackling when you're actually operating it. Now, the gain's sort of a set and forget thing. You don't generally change it while you're recording or mixing unless you've done something, and changed the gain structure. Or the guitarist has turned up on their guitar or something like that. But it's usually just a one-off adjustment, and then you set your level and you're done and use the fader for your actual mix. So not the end of the world, it's just for a little project studio, so no dramas there. We've given the pots a clean and lube, they've cleaned up okay, as well as the EQ sliders. So this one goes back to fight another day. Some mixers, like the Allen and Heaths for example, you can get in there and clean the pots just by removing the back cover, because each channel is its own PCB, its own vertically mounted module. The Behringers, the Mackies, the pretty low end stuff, it's one big board. So that whole surface, all the pots, all the XLR jacks, everything are PCB mounted, and the only way to get to them is to remove everything and take the board out. So you'd have to undo all these screws, all these nuts. Pretty labor intensive just to get to the pots to give them a little bit of a clean. So all we've done is clean the faders. So just bear that in mind when you buy one of these, that cleaning is a pretty big job. And generally, the majority of the mixers that come in here for service, it's usually physical damage, or just general dirtiness, like dust in the faders, just general humidity issues causing the pots to go a little bit scratchy. And 90% of the time they clean up okay with just a bit of maintenance. So just the time required. So I've got to charge by the hour here to keep the doors open and the lights on. When you're a hobbyist in your garage, you could probably attack something like that, and as long as you're careful and just do a bit of research before having a go at it, and don't do it on other people's gear, just do it to your own. So if you stuff it, it's your problem, not anyone else's. So anyway, I'll leave you with that one. Just a little quickie here to get back into it. There's quite a bit going on at the moment, so I'm finding it hard to get time to do videos, but I'll fit a little quickie in if I can. Little afternoon delight. Who doesn't like that? So I'll see you on the next one, champions. Have a good one.